The 20-meter shuttle run, or the beep test, is a progressive intensity test that measures your aerobic capacity. It gives either an athlete or someone trying to improve their fitness a baseline of where that aerobic capacity sits. It also will provide you with an estimated VO2 max score. The main reason why we run the beep test is for its simplicity and for the fact that we can get a baseline where we can compare future results from program design. So what we do in a beep test is we have an audio track that is going to provide us with progressive intensity. Throughout the test, you will see the intensity changes. It will get harder and harder as you run the test. Now, what happens is you have to be able to successfully complete the test by hitting the lines that you'd see during the test. If you can continue to hit those lines, you can continue to run the test. The moment you can no longer hit those lines in consecutive times, that is when the test is over for you. Once you are finished the test, you will then receive a score based on the level and shuttle that you hit. And then the practitioner can then take that information and give you an estimated VO2 max score. I like to use the beep test a couple different ways. I like to use it for the estimated VO2 max, but I also like to use it as a heart rate evaluation. I like to evaluate the heart rate per level that the athlete gets to. Also, I like to evaluate the heart rate when it comes down from the finish of the test to a resting state. And I like to measure how long that takes. So the beep test is a fairly simplistic test to run. You don't need much equipment. You need essentially your audio track. You need speakers. You need a tape measure. You need a heart rate monitor if you want to run the heart rate aspect of it. And then you need some cones to be able to set apart. So when we run the test, the procedures of the test are as follows. The practitioner must select a field or court that is relatively non-slip. I personally like to use a basketball court if I can. If I can't use a basketball court, then I would like to go to a track. Some people use fields. If you use a field, then it's best to make sure that the athlete either wears cleats for traction or make sure the field is dry so there's no slipping. Once you have selected your surface, the next thing you would want to do is then measure out the distance. So you would take your sets of cones, and I like to use 4 cones because I like to create 2 line barriers with those cones. You put 1 cone down, and then you measure it out to 20 meters. Then you put the next 2 sets of cones down. Once you have the cones in place and they're 20 meters apart, then the next thing you want to do is get the athlete to the starting point. Once the athlete's at the starting point, you then can explain the test to the athlete. The test is relatively simplistic. You need to make sure that they first hear the beeps and hear the audio track so they get an idea of what they need to listen for. And you also want to explain to them that this is a progressive test, which means the intensity starts rather low and builds up to something much higher. A lot of the test is timing to make sure that you get the beep, you get to the line on the beep. So you want to make sure that the athlete understands that it's not a sprint to start to get to the line before the beep. It's a progressive, slow movement, and it'll eventually be a sprint if they can make it that far. So get the athlete on the line, explain to them that you're going to start when you hear the first beep. You are going to jog to the next line, and you are going to wait there until the next beep happens. When you hear the next beep, then you continue. You keep doing this sequence repeatedly until the athlete can no longer hit the line in 2 consecutive tries. And that's a key point to the test, is essentially you have 1 chance if you make a mistake. So if you hear the beep, and usually this happens as we get down further to the test, if you hear the beep and the athlete runs and the beep goes and they didn't get to that line, they're not out yet. What they need to do is hit the line, turn around, and head back to the other line. If they can get to that other line and they hit that line before the beep, then they can continue with the test. If they hit the line and they continue with the test, then they keep going until, again, they can't get 2 consecutive turns in a row. So you will be eliminated when you miss those lines 2 times in a row. So, for example, if your athlete goes from the beep starts and the athlete goes, he's about 2 meters away from the line. The beep goes. Well, now that athlete has to turn, hit that line, and get back to the other side. If they are not at that other side when the beep goes off and they didn't hit that line, then they need to step off, mark their score, mark their level, mark their shuttle, or the practitioner can mark the level, mark the shuttle, and then they can go to their cool down and their heart rate resting evaluation. So that essentially how one way an athlete can be eliminated from the beep test or the 20-meter shuttle run. The other way is if they just no longer can continue. They just feel like they can't push any further. They've gotten to their limit, and then they start from there. So that essentially is how the beep test is run. It's 20 meters. It's 2 sets of cones creating a line. You have your audio track. You have your speaker so the athlete can hear the audio track. You have your heart rate monitor, and the heart rate monitor could be a smartwatch. It could be a polar heart rate system, anything that tracks heart rate. But ideally, a heart rate monitor is the way to do it, because what you're going to do is every time you hear another level, you want the athlete to give you his or her heart rate reading. All right? If you have a polar system that allows you to track their heart rate on an iPad while they're going, then you can write it themselves. But if it's just something like a smartwatch or a wrist heart rate monitor, then what you want to do is get them to essentially, once they get to the line and they hear the shuttle, speak up their heart rate so you know what it is. So from there, what we would want to do is track every level of their heart rate. And I'll show you in a bit how to track that and how to utilize it in terms of understanding a few aspects like, what their aerobic conditioning is, what intensities we might be able to push them to with their training. So the beep test, as I said, could be used one of 2 ways. We can use it to measure estimated VO2 max score and compare it to the standards that are provided with those VO2 maxes. Or we can do a level-by-level evaluation of the heart rate and a timed cool down of the heart rate as well, and see how long it takes for the athlete to get to a resting state. So that is the procedures and steps of the beep test. Now what I'm going to do is show you how to use the template that I created to track heart rate throughout the beep test. So this is the template I use to evaluate heart rate post 20-meter shuttle run or beep test. So what I've created is a few tables to be able to help with the data collection. Now, a couple ways you can do this is you can have this template on a laptop on the field and punch the numbers in as you go, or you can use a data collection sheet and punch these numbers in after. So let's just quickly go over what the numbers, the data points are and what we're looking for. So you can see at the top here, we have some baseline aspects of the athlete that we need to know. Things like their name, their age, their height, their weight, their resting heart rate. Once you get the athlete to do a physical readiness questionnaire, you should be able to get some of that information from there. If you have to measure them and check their weight at the time of the test, you can do that as well. Then a couple other aspects we put in is the estimated VO2 max. Now, I get the estimated VO2 max from a website called topendsports.com. And I also use their audio track for the beep test just to stay consistent with the estimations that they give and the standards that they give on their website. And then you have a spot to put their level and shuttle. So you can see this athlete scored a 7.4. Then this chart here, what we have is essentially their target heart rate zones based on their heart rate reserve. So in 1120, if you remember, heart rate reserve calculation is max heart rate, resting heart rate, and the intensity. So in this template, what I've done essentially has put what their heart rate reserve is, which is their max heart rate minus their resting heart rate, and that gives a heart rate reserve. And then I've been able to allow the spreadsheet to calculate each intensity for the heart rate reserve. So once you have that down, the heart rate reserve, and then when you start punching in the numbers of the athlete's heart rate for each level, you can start getting a little bit of a clearer picture of what intensity they are going in during certain stages. So if you can see here, this, as I said, this athlete got a 7.4. So we only had data points up to 7. And this athlete finished at 218 for 7. So essentially, he continued to 0.4 and his heart rate stayed the same. So what I would do there is put the finishing heart rate up here, which is 218, which is pretty high. And that's why we assume that that is his max heart rate. And you can see that we put 218 in his max heart rate in the calculation because he scored a 218. So you can see that after the second level, he was getting up to 173 beats per minute, which is, for this particular athlete, is in the fitness building zone. And then we moved into 191, which is moving into more of the higher end of the fitness zone. Then we go into 201, which is going to take him into high intensity. And then he finished off at the extreme, which is 95 to 100%. So that's why I like to evaluate the heart rate of the athlete per lap or per level, because it gives me an indication when we go back on a retest to compare what type of adaptations the athlete's getting, right? So let's say we take this particular athlete and we develop a 8-week conditioning plan based on these results. And we retest the athlete afterwards. And we see that after level 2 of the beep test, his heart rate's 150. And then level 3, it's 170. And so on and so forth. And he gets to level 10 when he gets to 218. So all of a sudden, we get a complete shift in his ability to run this test. So yes, this test will give us a good indication with how many levels he can get. Obviously, the more levels, the better the conditioning. And then the estimated VO2 as well, which would give us a standard to judge this athlete by, and also to be able to use that estimated VO2 as a data point for where it may lie. Obviously, this is a field test, not a laboratory test. So the reliability of that VO2 score is quite low. But in terms of just giving them something that they can use in terms of a score, it's something that I find useful for the athletes. You don't have to do the estimated VO2. You can just leave it at this is what level you got. You don't have to do the heart rate aspect. You can just, this is the level you got. We need to see improvements. But personally, I like to take as many metrics as possible when testing to get a better understanding of the adaptations of the athlete and to see where they are in current terms of their fitness level. Now, the other aspect or data point I like to collect for the beep test is the 5-minute recovery time. So you can see the athlete finishes at 7.4 with a heart rate of 218. Now, we get that athlete to do really moderate active recovery, so nothing too major. We obviously don't want them to just sit immediately. But we don't want them to move around too much, right? So we just try to get them to be as comfortable as possible and moving just a touch. I try to get them to stay relatively in the same place, and that allows their heart rate to drop. So then we see how fast that heart rate drops in a 5-minute period. So this athlete got down to 138, which gives a recovery range of 80. So why I like to put this into play is because this shows you the recovery time is a good indication of aerobic ability, because having a high aerobic ability or aerobic capacity will lead to quicker recovery times, because your body will be able to regenerate the oxygen deficit or debt that was created, and it will essentially allow the body to recover at a decent rate if you have a high aerobic capacity. So that's why in the beep test and another test we're going to go over, the 300-yard test, I like to use this 5-minute recovery time. So this particular athlete scored a recovery range of 80. And when we retest this athlete after an 8-week conditioning plan, we would like to see that recovery range be a lot better. We like to see it increase. If you look again here, you can see that the athlete's recovery is 50% and it's 142 beats per minute. So you can say that this athlete did recover, right? Ideally, I do like to get the athletes to a 50% heart rate, recovery rate when they're doing their work. Especially when we look at work-to-rest ratio. And this athlete was able to get to that recovery. Now let's take a look at how we can do the estimated VO2 max. Okay, so things that we need: age of the athlete, gender of the athlete, which is a male, and then the score. Then we can go to the top-end sports. We could enter the age of the athlete, the gender, which is a male, and then the level, which is 7, and the shuttles, which is 4. Then you just hit calculate, and it gives you this 37.8, which is a rating of below average for that particular athlete's ability. So then we can go back here, and we can type that in to 37.8. And I like to just put in brackets, below average. So now I have this data point here of 37.8. And again, when we retest, we can use that as a marker of improvement. Now, another thing I like to do is chart the heart rate. Again, just to see and give an idea of what the flow is while he's going through each level. So you can see that I have the heart rate charted, and then the levels so we can see where the biggest jump was, right? So when we get to level 2, and the reason why we had level 2 and we don't have level 1 for this athlete on the template is because he had a heart rate. The heart rate monitor didn't give us a reading for the first level, so we had to start at level 2. But you can see at level 2, we had about 100. We had 177 beats per minute, just under 177 beats per minute. So we had 173 beats per minute, and then we had about a 20 beats per minute drop increase. And then you can see as he gets to level 4, 5, 6, it's a little bit more of a steady climb. So that just gives me a little bit of indication between 2 and 3 that he had to jump from fitness to high intensity pretty quickly. Most well-trained athletes, we would expect them to be more in the fitness range in the 2, 3, 4, 5, 6, 7 levels. And then once they get into 7, start getting into the higher intensity. So this athlete wasn't particularly conditioned when they came into this test, and that showed on their results. So if I were a coach looking at these results, what I would essentially want to do is take this athlete through a conditioning plan, because they would not be ready to compete at this level. We need them to be at a much higher level in order to compete at a high range. So that's how I use this template in order to assist my data collection and evaluation of the test. If you have any questions about the template is in Excel and numbers on Brightspace. If you have any questions on it, you can send me a message and I'll get back to you on that. And it's really easy to add more levels if you need to. You just need to right click and then just add a row below. And then that will allow you to punch in another data point for the levels if you need to. All right. And then when you start entering data, it will put it on the chart as well. Okay. Thanks, everybody. This was the beep test. Hope you have a great day.